Hello, and welcome to this video on compound interest. We're going to calculate the following. First, what interest rate compounded monthly is equivalent to 2.5% compounded quarterly? And second, what interest rate compounded semi-annually is equivalent to 4.5% compounded monthly? We need to round answers to 2 decimal places. Equivalent interest rates are nominal interest rates with different compounding periods that result in the same future value of a given principal for any fixed period of time. Equivalent rates are used to compare the interest rates between loans and investments that have different compounding periods. And we have a formula that relates different interest rates, and that's the formula we're going to use to compute what we need to compute in this problem. So for part A, we have a J value that equals 2.5%. This is the interest rate, and the interest rate is given by 2.5%. So we have 0.025 in decimals. Remember that every time we use rates in a problem that concerns finance, we write the decimal equivalent or fraction equivalent of it. We have nominal interest rate 2.5%, compounded quarterly. So let's call this J1. That's telling us that the compounding frequency is 4. Interest is compounded every 3 months. And we need to find interest rate, the J2 corresponding to this J1 with this M1. So given that J1 is 2.5% and M1 is equal to 4, we can compute the periodic interest rate corresponding to this nominal interest rate. We have this nominal interest rate divided by the corresponding compounding frequency. So we do 0.025 divided by 4. And that fraction gives us the number 0.00625. With all of those variables clear, what we can say is that I2 is equal to 1 plus I1 raised to the M1 divided by M2 minus 1. And because we're looking for an interest rate that is compounded monthly, is equivalent to this one that is compounded quarterly, our M2 is equal to 12. The second compounding frequency is 12. So what we have is that I2 is given by 1 plus 0.00625 raised to the 4 over 12, and then take away 1. And then with this I2, what we get is that J2, the nominal interest rate associated with this periodic interest rate, is given by I2 times M2. So we'll multiply this whole quantity by 12. And when we do that, we get the number 0.024948, etc., which can be rounded off to 2.49%. So about 2.49% compounded monthly is equivalent to 2.5% compounded quarterly. Now for part B, we get to do something very similar. Now we want to know the interest rate compounded semi-annually that is equivalent to 4.5% compounded monthly. So here our J1 is 4.5%. That's 0.045 compounded monthly. So here we have that the first compounding frequency is 12. Then our periodic interest rate associated with this nominal interest rate is given by J sub 1 divided by M sub 1. So we have 0.045 divided by 12. That gives us a number 0.00375. Okay. So then I2 will be equal to 1 plus I1 to the M1 over M2, take away 1. M2 is, because we have an interest rate that will be compounded semi-annually, M2 is 2. So I2 turns out to be the expression 1 plus 0.03, and I think I missed a 0 here. So 0.0375 raised to the, and here we need to erase this part. Let's just erase that. Okay. Raised to the M1 divided by M2. M1 is 12 and M2 is 2. And then take away 1. So J2 is I2 times M2. So we're multiplying I2 by 2. And when we do that, we get the expression 0.045, 42.4, etc., which can be rounded off to 4.54%. So 4.54% compounded semi-annually is equivalent to 4.5% compounded monthly. Okay, so for this problem, we worked on finding nominal interest rates, well, or better, identifying nominal interest rates and compounding frequencies. Then based on that, we worked with periodic interest rate. And then we used this formula right here to relate to find equivalent periodic interest rate. And then with that periodic interest rate, we found the nominal interest rate by multiplying the periodic interest rate by the compounding frequency. Okay, so that's it for this problem. If you have questions, let me know. Thanks for watching. Bye-bye.